This morning, we will talk about how to connect ICP applications, canisters, with Web2 servers. This is a feature that was not around when the Internet Computer was launched. It has been added, I think, 1 year after the launch, through a lot of efforts and engineering, and it's super cool to be able to do HTTP outcalls, essentially being able to directly call a Web2 server or a Web2 API directly from your canister and having the answer back and also part of the ICP consensus. So this has been an issue for all blockchains since the early days of the smart contract on Ethereum. Essentially, the problem is how do you create a smart contract that can take a decision based on information from the real world, because information from the blockchain world, it's easy to make computation and condition, but how do you input information if you don't have a trusted source, a trusted party? And that has been an issue, of course, to trust someone to be able to write on the blockchain. So the solution that we have, for example, the problem that is often used is the problem of if you build insurance system for like farmers that are automatically refunded in case of a thunderstorm or bad weather. How do you input the weather in the smart contract to deliver the funds? The solution that has been around and that is being used most of the time is this Oracle solution. So an Oracle is going to be creating this Oracle contract on the blockchain and allowing the Oracle to write in this contract, and then the rest of the infrastructure will communicate through calls on the blockchain. But this Oracle is a trusted party that you essentially add to your stack. I'm not sure what's the latest trust assumption for Chainlink. So this is the most common and biggest Oracle, Chainlink. I haven't looked too deep into it since I would say 1 year. So maybe I'm not 100% up to date, but I know there is a specific security assumptions that you have to take into account. Well, and also it's a new piece of infrastructure that you have to add to your stack essentially. So on the IC, it's different. There are still some security and trust assumptions that I will go into, but the approach is more native in the sense that canisters can directly make HTTP outcalls and they don't need an external service. So it's actually baked into the protocol. And as a developer, it feels very natural, and you can just request any HTTP request through the management canister. So I'll explain what is the management canister. And it's as simple as doing this await management canister.http request, then your request, waiting for the answer and processing the answer. Now, how does it work? So we have this little animation. So the problem that we could face is that how do we make sure that every node in the ICP subnets agree on the result of the request? Because if you do a request and there is like a timestamp, or even if it's the weather or it's the price of an asset, like if you call exchange like Coinbase or Binance, and you want to know the price of Bitcoin at a certain point in time, the fact is that all the nodes are going to send slightly different requests at slightly different times, even if it's just a few milliseconds. And so they are going to receive a different answer. But we are working in a distributed environment with a consensus. And so we need one answer that we can consider as the true one, and the one that we will use for the state of the canister. So essentially, there is a step one where every node is going to call the API in question. Then there is a step two where they have to go into some kind of agreements on the results of this request. And when they have agreed, essentially it returns the result to the canister. How to reach consensus? Oops. So essentially, it's the same security assumptions as the ICP consensus, which is why it's called native approach. You still have some security assumption because, of course, if you have only nodes that lie to you, they could return a false HTTP request, but it's the same number of nodes, so it's 2/3 of the nodes. That is exactly the same as the ICP consensus by itself, so it doesn't add any security assumption. So the first scenario that I want to talk about is a scenario where you have 3 nodes. You have 2 nodes that receive sunny weather and the other one receive a thunderstorm. Of course, in that scenario, the majority of the nodes would impose their request. So you would essentially see from your developer perspective the sunny weather. But the fact is that usually it's not as simple as it's sunny or it's a thunderstorm. Usually, most of the time, what you receive would be like a text value or a number value, and you're going to receive slightly different answers. That's what I was saying about previously. You were going to receive like 27.5, 27.4, 27.26. So essentially, as human, when we look at this, we think, oh, the nodes agree on the value. They agree the time is the weather is 27.25. But from a computer perspective, this number is different from this number, that different from this number. So essentially, you have to provide a transform function, which is here. For example, in that case, if you provide a transform function that only keeps the decimal part, the non-decimal part, so you would receive essentially 27 from this one, 27 from this one, and 27 from this one, and then you can agree that the final result is 27. Could also do like an average or something where you have a slight, maybe like 1 or 2% tolerance. And if any value deviates from the average by 1 or 2%, you consider this as false. There are many ways to do the transform method, and it's actually something that you probably want to deal with depending on the scenario. But yeah, most of the time it's gonna be this scenario. So essentially it's gonna be all the nodes calling the API, they receive a slightly different value. You have this transform function that you provide as a developer, and you have a certain tolerance that you agree on. And then if it's within that frame of tolerance, you return the consensus. The consensus value returned is the one that you see here. So the use cases are very broad. I mean, any application on the IC could use this, and actually most of them do. There is a exchange rate canister, which I will show you in a few moments. The exchange rate canister stores and certifies the values of pairs of assets. So for example, at any point in time, it's able to let you know what is the price of ICP. This is actually used by the IC itself when you want to burn ICP for cycles. You get more or less cycles per ICP depending on the price, so that it's always the cost remains constant. And so to do that, you need to know the price of the ICP token. And actually the protocol is using this exchange rate canister. Of course, you have ICP, but you also have all sorts of pairs of currencies. So euros to dollar, or Bitcoins to euro, all sorts of exchange rate that you can get. And they are also certified by the canister. IoT devices. I could show you also a project that is essentially a gateway for IoT devices, and it's leveraging this HTTP outcalls to communicate with the devices directly from a canister. So it enables you, for example, to control a physical device from a canister. Something as stupid as being able to control the temperature of a room, or controlling a light off or on, or controlling a board. Anything you can think of. Ethereum, the integration with Ethereum between the ICP network and Ethereum leverage the HTTP outcalls. Social media. So here I'm talking about Web2 social media. So being able to have, for example, there is an account on Twitter, which I could show you, which is controlled by a DAO. And essentially it's using a canister that controls the Twitter account. And I'm pretty sure they leverage HTTP outcalls. You could also leverage HTTP outcalls to create some kind of bridge between Web2 services and Web3 services, being able to query information or post on social media from a canister. Payment gateways could be one. Of course, we have crypto and we have wallets and we have standards and ledger, but there are still some already existing payments infrastructures like Stripe that are very well known. And I'm guessing that, I don't think anyone has done it, but I'm guessing that it should be possible to do some kind of integration with an ICP application and Stripe. AI, finally. So in that regard, being able to interact with AI model and large language models through HTTP outcalls. There are also people trying to run models within canisters. There is a decentralized AI working group that is pretty active, but I'm not 100% up to date on their findings at the moment. So now I want to show you the exchange rate canister. So the exchange rate canister, I don't know if, let me see. I think I had it. No, it's here. So okay, so first I would like to show you this code sample, which is an HTTP GET request in Motoko. And the purpose of this application is to get the price of an asset. So I'm guessing that this is the price of ICP. The way to get this working, so the way to get an HTTP request is to use the management canister. So the management canister is a canister that essentially is not really a canister, but can be considered like similar to a canister. We will see it here. So the management canister is the canister with this canister ID. So you can see it's pretty specific. It's not like the same length as others canister, and it's shorter and also very, very strange. This is because the management canister does not really exist as a canister, but it's an interface from the IC system to being able to call system methods. So it's very useful as a developer because you can use it to do HTTP requests, but you can also use it to do installation of other canisters. For example, if you want to create canister from your canister, you would use the management canister. You can also use it to interact with the IC system. So if you're looking for like calling, having like information on your canister, like canister status, all sorts of things. Here we only have the HTTP requests, but there are more methods that we could add on this canister. Once you have that, you just need to specify the argument. So here it's here. So of course the URL that you want to query, the headers, the method that you want to call. So method is gonna be either a get, a post, or head here. The transform method that I was talking about is here. So it's transform row response function, which is here. So here in this example, we are going to call the API of Coinbase. So api.pro.codebase.com. And yeah, it's going to be ICP USD. So the price of ICP. Then we have the transform context, the HTTP request by itself. Then we need to add cycles. So we need to pay actually for it. It's quite costly. So it's reasonable cost, but still some cost because it's an expensive operation that requires some work in the consensus. And so you would need to do cycles.add. So essentially you're taking cycles from your canister and you're adding that in the message. And then when the message returns, the cycles are given back to your canister minus what has been used for the request. This is something that is a little bit challenging because you actually need to know beforehand how many cycles you're going to use, or you need to be generous enough that you give so many cycles that it's gonna be enough for the request. Then you call this management canister, and then you receive the request. You need to decode it. So yeah, because here you're receiving like a encoded version of the body of the page that you've called. So you need to decode it and then return the decoded text. So let me try this example and show you that we can do it. I'm hoping that it works locally. So Motoko. Okay. Now, if we take a look here, so we have our candid UI here. And if we get this, we should be able to get the ICP USD exchange. So let's see. Yes, we have the values. So that's great. We can actually do it from local. We can call so this is like the real values. I'm curious if we could do, maybe this is May 1. Maybe we can change the value so we can try today. So what is the Unix time of today? Let's say 9 hour. We take this. And 9 hour and 1 minute. So it's gonna be, yeah. Oops. So it should be Friday, February 9, February 9. UTC. And so now we should get something different. Closer to the current price, which I believe is like 12. Yeah, so that's great. Okay, so that's how you would do an HTTP request. This one is a GET, but you also have an example for the POST request. So if you take a look, um, this one is a POST. The challenge with the POST request is on the other way around. So when you get something, you have to agree on the value, but if you post something, you have to make sure that you don't post it multiple times. So if you think about it, all the nodes are going to call this post. requests. And so if you want to post a message or something, you will multiply by the number of nodes in the subnets, and this can be a problem. Fortunately, there is something called idempotency key, which can be used in the header of the post request. And so if the server that you're calling implements some check and you have a correct key, it's only going to use one request, to take into account one request. So in that case, it's a little bit different because it's the server that you're calling that has to be implemented some check or that has to be modified. So if you have access to this server, it's great. If you don't have access, I think it's still hard. I don't think right now we are able to use only one node to make. No, we cannot because it would be problematic. But I think they're working on some solutions in case there is only like the server that you're calling doesn't implement this those types of headers. But the procedure is the same. So we are also calling the management canister, adding some headers. So this, you will need to look at the documentation of the API that you're calling. And then same, we are adding some cycles, making the request, and then decoding the response. Let me show you maybe the exchange rates canister. And I will also show you the management canister. So if you want to take a look here, it's one of the first canisters that was leveraging this HTTP outcall method. And the second thing is the management canister, but the management canister, it's quite hard to find information about it. Well, no, it's not here. Yeah, so this book, the Internet Computer Interface Specification, is a book that contains like everything that you would like to know about the IC, but it's very low level. So if you have the bravery to read that, you can. It's super interesting, but it's also very hard to understand. And here they talk about the management canister. So it's, let me see. It completely changed. It was not like this before. Mm. Okay, there is a section about the management canister. Okay, here. Yes, that's what I was looking for. So this is the interface description for the management canister, and it contains every single methods that you could call on it. So you can see create canister. This is how you would do it if you wanted to create programmatically a canister. Update the settings of a canister. You can update chunk inside. This would be to upload the WebAssembly module in chunk. You could install some code in a canister, of course, if you have access to the controller of this canister. Uninstall code, start canister, stop canister, canister info. So everything that is like, I would say, system settings, you have access to it through the management canister. And the HTTP request, as well as all functionalities related to the ECDSA that we will see tomorrow, which is the threshold ECDSA, is how you are able to create distributed signatures for. So ECDSA is a cryptographic protocol that is used in Bitcoin, Ethereum, and most other blockchain and cryptocurrency. And so you are able to generate keys, pair of keys, or signatures through this management canister, as well as interfacing with the Bitcoin network. So you can see here, you have the Bitcoin interface and so on. So yeah, if you're curious about this, I'll just. What can I do with the declaration service? Which one? Service. Service. Yeah, service just means actor in Candid. So this is a Candid file. If you look at Motoko file, it would be actor. So the corresponding Motoko file would be an actor. Essentially, it just means yeah, service. Like it means that those functions that you see are the public function that you can call on the canister. Motoko students. What is this? Oh yes, Orally is a good project. Yeah, and that's a good project to talk about today, actually. So they are leveraging HTTP outcalls to create a multi-chain Oracle experience. So they are going the other way around, actually. They are using so I think it's more for projects that are outside of the IC ecosystem, because if you are on the IC ecosystem, you would not necessarily use their infrastructure, except if it depends how they, um, let me see. So they are leveraging HTTP outcalls and ECDSA, which we will see later. Pretty. Yeah, essentially what they're doing is they are leveraging those features. They are aggregating data, signing the data, so creating like signature on it, and then they can send those pieces of data to external chains, other chains, and they can they can essentially be like a multi-chain Oracle solution for any project. And they just have to, yeah, they can declare like they can deploy contracts on other chains and make the link to their infrastructure. So it's pretty interesting. One question I would have for them is how, well, for ICP project, why would you want to use them instead of doing the calls by yourself? Because you are essentially adding a trust assumption by using them. For other chains, I understand. For ICP products, like if you're native to ICP, I think I would still do my calls myself. Maybe if they have some kind of interface and they have some easy, like they make things easier, because it can be a little bit rough to do HTTP out calls. By the way, there is I think it was released a few weeks ago. No, no, it's not what I was looking for. Uh, Cheaper without doing your own out calls. Yeah, it would be probably cheaper. I mean, I don't see how they could make it cheaper than doing because they are essentially doing, so they are leveraging for example, for prices, they are leveraging the exchange rate canisters. So it's all a question of how nice the interface is. But then the work and the cycles and the costs, I don't see how they could be cheaper than doing it kind of by yourself, because they are like adding some steps. But I totally understand that. I think it's a great solution, because most projects, they don't necessarily want to dive and build their own solution for a small purpose that they have. So if Orally can provide them with a simple documentation, simple interface, works on any chain, and costs that are reasonable, then I think this project has a lot of potential. Um, Actually, I met the founder well, it was 1 year ago already, so it was a long time ago, but they've made a lot of progress since then. That's about it for HTTP outcalls. I don't have more, because I mean we could dive more into the example of the post, but I think we've seen the get. The post is very similar. Yeah. So I don't have more to say. We can leave it there. And I see you in 30 minutes. The next lecture is gonna be, it's not really part of the bootcamp. I mean, it's part of the bootcamp because everyone always asks me, but it's not part of the projects and it won't give you more Motoko knowledge. It's gonna be front-end knowledge. So it's gonna be JavaScript. Just to warn you, we will do integration with internet identity and try to log in through internet identity. And I'll explain how identity and authentication works on the IC. So it's gonna be 100% front end. And yeah, see you there, everyone. Goodbye.